Hello. So today we are going to learn about our new topic, ionization energy and successive ionization energy. So what is ionization energy? So it is actually the amount of energy required to remove an electron from 1 mole of an gaseous atom from their outermost shell to form a +1 oxidation state. This is what actually ionization energy means. And successive ionization energy is the continuation of this process. That is, when one electron is released from the outermost shell, if the second electron is to be released from the same shell or from the next shell, then it has to take another energy. It has to undergo a process which is known as an endothermic process to take energy and release the second electron from its outermost orbital. Let's see how it works. So suppose we have an element, say sodium, and it releasing one electron. So what will it become? As electron is negatively charged, this sodium atom will have a positive charge, +1 positive charge. This release of electron from this sodium atom occurs from its last shell, that is its ultimate shell or the shell with the highest energy. Okay, that is the outermost shell. So if we see what is the electronic configuration of sodium, then we will find out what this first ionization energy will actually look like. So the atomic number of sodium is 11. Okay, so the electronic configuration will be 281. Okay, so as sodium is releasing one electron from its outermost shell, it is gaining an octet. That is, it is gaining a nearest noble gas configuration, okay, which is neon. So this first ionization energy tells us a lot of things about an atom. Sodium with 281 will release an electron to form Na plus, which has a configuration of 28. Now, if second electron has to be released from this Na1 plus ion, it will again take the energy from the surrounding to release the second electron. But the amount of energy required in the first case, means in this case, will be much lesser than the amount of energy required for the second case, because not only it has to break its octet stability or a stable noble gas configuration, but also has to withstand the positive charge that it has already accumulated on itself. So if let's say this is X joules or kilojoules of energy. So when Na plus releases the second electron, that is the successive ionization energy, it becomes Na2 plus, and the configuration will be 2 and 7. From 2, 8, it will be 2 and 7. And let this be Y kilojoule. So we will say Y is much, much greater than X. Okay. From this idea, we can say that whenever we see the ionization energy, it depends on some of the factors. Okay, it depends on some of the, because you see here the second ionization energy has drastically increased. If first ionization energy is X, the second ionization energy could be 2x or 3x, but in this case it has drastically increased. So this drastic increase in the ionization energy or successive ionization energy tells us another thing, that in which period or what is the place of that element in the periodic table. Okay, if it is not sodium, if it was magnesium, then we would have a different electronic configuration. So if we have magnesium like Mg, so it will have 282 configuration. So after releasing one electron, it would have become Mg plus 1. Let's it be W kilojoule. Now Mg plus 1 will release another electron to become Mg plus 2. Let this be U kilojoules. Okay, so from 281, it will become 28. And here it will become 281. So now, here, as we speak, the first ionization energy, W kilojoule, okay, will be greater in magnitude than the second ionization energy. Means in practical, this will be the case. U is greater than W. This is the practical case. If it is 100, then it will be 160. If it is 100 kilojoule, say, I'm just saying it is to be 100 kilojoules, then this next one will be 160 kilojoules. So yes, the second ionization energy is more than the first ionization energy. But if you see the magnitude, for releasing one electron, it requires 100 kilojoule of energy. The atom of magnesium requires 100 kilojoule of energy per mole. But in case of the second ionization energy, it requires only 160. That means only 60 kilojoules of energy more. And in this case, if this is 100, if you take X as 100, then it would be nearly 10,000 kilojoules per mole. So this drastic change determines what type of configuration the element is having. From the ionization energy data, we can figure out in which period the element is present, okay, or which is the group number of that element. Okay, these two things can be predicted from the ionization energy values. Exact period number may not be identified in that manner, but yes, you can have a guess that yes, it may go like this. Okay, so this is what the ionization energy actually means. So let me recapitulate it. Ionization energy is the amount of energy required to release an electron from the outermost shell, of an isolated gaseous atom, or 1 mole of isolated gaseous atoms. The amount of energy required to release an electron from the outermost shell of an isolated gaseous atom, or 1 mole of an isolated gaseous atom. Okay, this is the ionization energy. It's called ionization energy. Okay. Then the successive ionization energy will be the amount of energy absorbed in excess to release the second electron from the outermost shell, new one or the last one. Okay, suppose in this case, in the above case, as we have seen that in this case, the first electron and the second electrons are being removed from the same shell, okay, from the third shell. But in the first example of sodium, the first electron is being removed from the third shell, but the second electron is being removed from the second shell. So this is the main difference. Okay, so between the successive ionization energies and the first ionization energy. So let us take an example. Let us take a question. Suppose this is a question. If the 5 successive ionization enthalpies of an element are 800, 2427, 3658, 25024, and 32824 kilojoule per mole. The number of valence electrons in the element is. If this type of question is been given to you in your exam, so what will you do? See, at first you have to write the ionization energies. Okay, ionization energy. So, and here it is the value. So first ionization energy is, I think it was how much? 82427, 800, 2427, 3658. 800, 800, second, 2427, third, let it be 3600. Okay, fourth, 25K, and the fifth one is 32K. Okay, 25,000 and 32,000. And fifth one is 32,000 approximately. Okay, I'm not writing the actual data, I'm just giving you an example. So now the question is, where does means this element has how many valence electrons in it? Okay, now as you see, you have to just do the difference between the first and the second. When this is 800, this is 2400, means a difference of 1600 there is. Okay, between the second and the third, what is the difference? It is of 1200. Okay, now between the third and the fourth, what is the differences? It is not double, not triple, it is a lot more. It is nearly, if it is 4000 also, it is 2100, means 7 times more. Okay, 7 times more. Okay, so this is what you can say, that the third, when you are releasing the third electron, when the element is releasing the third electron as it is approaching the fourth one, so here it has some inert gas configuration. Okay, this has some inert gas configuration. Understood? Configuration. Likewise, you can say that as here the difference is about 1600 and here is 1200. So you can say that there is also some extra stability in during the removal of the second electron. There is some, means the element is facing some problems, or if they have to take much more energy, double this energy, means 800 plus 800 is 1600, but double the energy. Okay, so from the first ionization energy, so the second electron, while the element is removing the second electron, it is also facing a bit difficulty. That is why it is taking a lot of extra energy compared to the third ionization energy. So from this data, from this data that has been provided to you in the question, you can say that the element has three valence electrons. Okay, you can say that the element has 3 valence electrons. Okay, so this is what you can say. So this is where we are ending the class. Hope you have enjoyed it, and we will come back with a new set of questions. Bye-bye.